Hi, it's Tim from DWIT 3D Canada. Hey, listen, so I went ahead on my last video on the Windstorm S1. I went and took the voiceover portion of my video, ran it through AI to give me a new voice. And the results are, well, interesting and hilarious. So I'm just going to share them here. Watch it if you want. If you want a good laugh, just watch it and listen to certain portions of it or all of it. It is hilarious. I just thought I'd share that. Take care, everybody. Bye for now. All right, let's open the box. It arrived in perfect condition, remarkable considering the international shipment from China. That left a strong impression on me. We'll take off the top cushioning and look at that protection. The first item that catches our eye is a little thread roll. A standard 250 gram spool of white sample filament. Not a fan of white, but it's what we've got. Anyway, we have the filament spool and then our power cord. Clearly, there was a squeeze to get this into the box, so I had to get on the floor and hoist it up with some effort. But it was securely cushioned, and I didn't notice any visible damage. As we unbox the printer, it's secured with straps to hold it in place, completely intact and extremely well packaged, as I mentioned. Just a typical pair of snips. We've all got plenty if we review 3D printers. Included is a basic set of Allen wrenches. They have straight ends, not ball end, nothing fancy, just the usual Allen wrench set. Next we open up and there's a USB cable, yet another one for the collection, and also a USB thumb drive, which contains some sample files and includes some software and so on, as well as a couple of example print files. Here it is. Next up, we're taking out the spool holder base from the box, which goes through the spool. A few screws, a pair of bolts, that's all required to assemble the machine. And here's the spool holder itself. This will insert into the printer's top, as you'll notice shortly. It accommodates both standard and slightly wider spools. Based on my experience, it fits all spool sizes I own. Right. All right, the machine arrives in two sections. We've got the top, the gantry part, setting it aside for the moment. The foundation is sturdy and heavier than it appears, not as lightweight as one might think. Currently required.
Made entirely from cast aluminum.
So apart from the front panel you're looking at, the entire structure is made of aluminum. At the front of the printer, you'll find a USB port, a micro SD slot, and a USB-C port. Also, a small switch for resetting the screen. On the rear of the printer, we find our usual USB-A port and a spot to connect the printer and the power toggle, just the simple essentials. Oh, and two openings there for attaching the gantry. You'll observe the distinctive bed design. It's a recessed style, which is novel. It includes a flexible PEI build plate featuring alignment pins for repositioning. Secure the plate back once you remove your print from the bed. Right, let's take a look. Proceed to assemble the gantry. As previously mentioned, this printer is mostly wireless. There are no visible cables. You might wonder about the lack of visible cables, but a closer look will reveal why they're concealed.
You'll notice that
here's the connecting pin, which plugs into an outlet in the base, providing the power and connections for the hot end and the motors. Simply just place it on top like this, and then we spin it around and fasten the pair of bolts. That pretty much sums up the printer's assembly. Once those bolts are secured, the printer is set up. Just attach the swivel spool holder on top like this, and we place a filament spool and we're all set. The assembly of this printer is super fast, and there's nothing to it, and you're finished, that's all. let's check out the screen. It's a pretty unique and different kind of display than what I'm used to seeing. Full color display, very responsive touch screen on this device. Hit the print button. You can choose to print from the TFT, micro SD, or USB card. And now we delve into showing various settings available. It has something known as terminal. I'm unclear about its purpose. Seems like it's for direct coding, setting up the software. Let's show where some program we're dealing with, however. Now we are able to go through this menu to disable steppers, initialize cards, and restore settings from EEPROM, among other things. If we delve into the settings here, we have various ways to connect the printer. Again, some of these features are operational, others aren't. Remember, it's just a prototype. Going through these display items and menu options, some function and others don't. This is a prototype printer. That's pretty much anticipated. Right, I've been tinkering with some stuff here. Here's an instance where it might get slightly tricky. The system is in early development, so when the display freezes, we simply press the reset button. This will reboot the screen, after which we can proceed. Yeah. So as we revisit the main screen, we'll explore several features once more. Let's tap on the, we've already covered this, there's an emergency stop button. It completely stops the printer. There's a shutdown option to turn off all components like heaters and fans. And then if we head back this way, here's one more and yet another. Another spot where it seems glitchy. So we can tap the screen for setup, but there's no exit from that situation. So once again, considering this is a prototype printer, there will be problems. This is one of them. It keeps saying that the settings didn't work, so we just restart the display and continue. Next, we'll revisit the menu, delve into settings, and explore the machine settings so we can tweak our steps per millimeter on the X, Y, Z, and extruder. Certainly, you'll encounter the expected things when you delve into these menus, as they give any updates or firmware. I'll apply them. Delve deeper into these matters and we'll delve further. What they all do. Indeed. Now, here's a potential upcoming feature. There are settings for LED lights, though I've spotted no LEDs on the printer itself. I guess this is meant to be a feature, possibly something for upcoming updates and parts of the printer. So again, we'll continue to navigate the menus here so you can get a glimpse of what's happening. Some features, as mentioned, are not operational at the moment.
In time, sure.
We understand the reason.
Yes, so that's good.
It seems we can simply reset our EEPROM.
Use as necessary.
We'll dive straight into it. PID tuning can be done right on the display, which is a great feature, common in many printers today. We can fine-tune the heat bed and the nozzle's temperature control. Yeah. No, I won't edit out those minor hiccups because I'm only human.
Goodbye. Excuse me.
We're able to tweak some offsets here, and there are quite a few intriguing options available right now. I'm not completely certain about their usage. This printer came without instructions. It's a prototype manual with it at the time, but I'm sure that's something that will be to be given in the future, so we'll leave it at that. Keep going through these features here, and if you have any questions or want to see anything more specific about some of these features, just go ahead and leave questions in the comments, and I'll try to answer or test features you're curious about. Yeah, so we have a few different defaults that we can set here as far as auto leveling, etc. It includes an inductive sensor. It's built into it, which we'll see later when we check out the Hotend. And there are settings in here as well for BL Touch. So I believe there's a variety of options for different leveling methods. There are several tools on this printer, which is quite interesting. Perhaps they'll settle on just one eventually. So I'll proceed going through here. What's up next for us to check out? Let's find out. Okay, yeah, so we are running Marlin on this. This is updated as of November 14th, 2023. And it is, I believe, should be the latest version of Marlin that's on. At this moment, that's what we're focusing on. Then we proceed with the usual positioning, shifting, and ejecting, and once more we encounter semi-automatic filament loading, semi-automatic filament. It's partially automated loading. I mean, you must manually insert the filament into the hot end for it to load. Here we have all the movement controls, and as you'll notice, they mostly respond as I press them. The touch screen is extremely responsive, something that pleased me a lot.
I've encountered touch screens on attractive devices.
Those are, it
not as frequently.
reacts swiftly like this one, so seeing this was quite satisfying. Let's get started. This is our chance.
Insert and remove filament from our extruder.
We can adjust loading and unloading speeds, set the distances and the amount of filament to retract. One observation about this is that it requires shipping, so you load a bit more to purge some extra filament while loading. Automatic bed leveling, editing, and validation of the mesh. Now an intriguing feature named DWIT has surfaced. Its function is unclear to me at this point. Often it's about ensuring the print bed is level. Nevertheless, we'll get the hang of these features as we progress with this printer. We're able to adjust our preheat settings for various materials here. Naturally, I'd likely never go beyond, avoid using ABS or nylon, given it's an open frame printer, though there are presets for various filaments. Still need to find the settings. Haven't programmed those just yet, but we'll explore that later on. Additionally, there are familiar controls typically found on contemporary printer displays. All right, then we'll skip ahead a bit. It has some settings for a BL Touch if you have one or if it's included, allowing you to adjust the probe offsets. You can switch your BL on or off. Backlight off. I'm not entirely certain of the mechanism, yet we'll solve the puzzle. It comes with automatic bed leveling. You can set bed leveling and it'll store in the EEPROM. That's the display overview. Now let's proceed to some printing. Off we go. Let's begin by initiating a print. The initial print is a test piece that was included on the flash drive, and it's known, if I'm not mistaken, as filament support or something along those lines. Anyway, I'm clueless about what that is. Regardless of whether it's functional on this specific printer or simply included as a demonstration, it's acceptable. Whenever you notice the timer on the screen, like I did a few times, that means it's real time. I haven't accelerated the footage, but I will for the video. To avoid boring you during the full print process of this item, we'll shorten it. I've slowed it down occasionally to real time just to show you the speed. This printer's speed, marketed as a fast printer, I suppose.
Or since it's rapid.
Indeed, a printer. Clearly, this has been sped up. We'll reach a moment on the second and third layers where this is actual speed. This is happening in real time. It's quite a speedy printer, even more so than other bed slingers I've used, I'd say. Many companies are raising the bar for speed in bed slinger printers, and this brand is definitely keeping pace. So if you catch that sound, that's a vacuum cleaner running overhead in the living room. Excuse any stray noise you might hear. Quickly moving through this video. All right, let's speed this up and get it done. And I was quite taken with the quality of this print, given the pace at which it was produced. And here we are at the end of the print. I just skipped ahead. I'm not sure what this part is meant for. It was a test print from the USB stick included.
And with the printer. So we
wrap it up here and we'll remove it from the bed. The print turned out nicely. By the way, at first the filament didn't adhere to the bed, so I had to apply some 3D lac. So to assist with the poor sticking, attractive initial layer or base, and the upper layers appear quite fine. Overall, this print seems excellent. We also proceeded to print the benchy that came on the USB drive. This print won't be as perfect as the initial one, and here we'll encounter one of the printer's first problems, cooling. You'll observe the absence of cooling ducts aiming down at the nozzle. That's due to their unique setup.
The cooling setup on this printer.
It was unlike anything I've seen before, really. Personally, I'm skeptical about its effectiveness for cooling prints, especially with such high expectations. So this printer operates quickly. A high-speed printer, it's excellent, but enhanced cooling is essential for effective high speeds. Looking at this benchy, right as it's removed from the build platform, you will notice the cooling problems. I don't need to remind you that this is a less than perfect appearance.
What is a
Out
Tiger?
there, given it was roughly a 17-minute print, the cooling was awful, and that's due
Thus
to
the design of the cooling system.
You'll notice how the cooling works. Once we open up the hot end, I'll explain it then. That concludes our printing examination for the time being. We just crafted several distinct items for testing purposes. We need to resolve some cooling problems before we can proceed. I believe we can print various sizes of models. Let's examine the printer's interior now. Here we are. We removed the flexible bed, and oh, there are 4 screws that we need to eliminate to clear out regarding the printer bed. So let's quickly go through these. I'm not super quick. Once the bed is removed, you'll see no cables. It's a wireless printer with 4 connectors that plug in. The bed is nicely powered. There are no loose wires at the bed's rear to concern us,
providing
whether it's bent or not. So be it.
There's a different cover here. We're about to
Take off the cover by unscrewing the 6 screws to see what's below. That'll just slide off the back, and it's got some padding there, I think, just to dampen the vibration on that plate because it is a thin aluminum plate.
This is Duck Young Lee from NBC News.
Let's rotate this and observe what's happening on the inside. So you'll notice the cables up there that now link up to the display. Now, there's a method to remove the entire electronic device, but you need to unplug many cables. I haven't tackled that yet, but might in a future video. Here's a clear view of the belt running along the dual vertical linear rails, along with a close-up of the belt's connection point. That's about all for the interior. Let's move on and check out the hot end now. Removing the Hotend cover is quite straightforward. It involves 3 screws, and then the plastic shielding comes right off. You'll see there's an inductive probe inside here. All your standard wire connectors are here. You've got an inductive sensor and the hot end cooling fan. If we remove, looking at the sock, it's got what's now typical these days with thermostat and heater integrated into the hot end, which fits a standard M3 nozzle. Now, looking over at the hot end's opposite side, we can take another peek here where the wires connect to the daughter board or a breakout board there. You can now observe the heat dissipation component on the heated extremity. Over here, you'll notice the cooling area. If you notice the fan at the rear, everything there is for cooling the part, that's the fan directing air towards the nozzle randomly. In my view, it's an inadequate method for cooling components, particularly for high-speed printers. This assembly comes apart easily if you need to service the hot end. It was just 2 screws there to take off the heatsink. Putting it back on is just as straightforward as pushing that up and replacing the pair of screws, but take a peek at the rear to spot the fan. That's the cooling part. Right there, that's the cooling fan. That's it for cooling. There's no way to direct the airflow, which honestly isn't ideal. All right, that wraps up the hot end discussion for the moment. I just wanted to open up the top here to take a look inside.
the way.
2 Z-axis rods, 1 set of linear rods, and another set of threaded rods for stability. And we have a single motor running these rods. I wanted to open this up To demonstrate the belt routing, which is also quite intriguing, they are synchronized by this distinctive belt design. I call it unique because it's the first of its kind I've come across. And they've got a really neat method of tightening here, so you can adjust your belts. There are a few screws involved in that process. There's a plastic part at the bottom where that single wheel is mounted. Just loosen these two screws and you can adjust that pulley to tension your Z-axis pin.
That's fairly interesting, Bill.
That mechanism ensures both Z-axis rods remain perfectly synchronized.
So we did another quick test.
Print out this FlexiFactory Dolphin model. I'm utilizing Polymaker materials. Polylactic acid filament, just showing the current cooling system's flaws. Notice the details on the fin. The bottom layer is all good, mostly printed well, but it's got serious cooling troubles to sort out. We'll talk about that with the producer as we go forward.